All right. Welcome everyone. Let's go ahead and get started for the day. Just a reminder that the second homework assignment is out, so I know at least some people have looked at it because I've talked to you about it, which is great. Let me know if you have any questions or get stuck. It's definitely trickier than the last one, in my opinion. So, would encourage you to take a look at it sooner rather than later, just to at least start the gears turning in your head so you can start thinking about it, what you might have to do. But yeah, let me know if you get stuck. Let me know if you have any questions, need a push in the right direction. Happy to help out with that however I can. Does anybody have any questions right now about the homework assignment or anything about the calendar or anything else before we hop into Git? Alrighty, great. In that case, we're going to spend today talking about, well, I mean, this is honestly one of the topics I get asked about most often. It can be a complicated topic. Hopefully today we'll get you used to some of the more common operations you might be expected to perform on repositories. These are just going to be good skills, good practice for you to have. And to be honest with you, we don't actually set students up very well for using Git in the majority of the classes that we teach here on campus. It's just not something that's often used in the same way that you would expect it to be used in the world at large. We introduce students to it very early on. The very first day of the introductory class, of course, we get students set up with Git and setting up repositories. But other than just the good old commit and push to turn in your homework assignment, many classes, most even probably don't use Git beyond that, I wouldn't think. And I mean, it's kind of a disservice because there's a whole lot that Git has to offer. It can also be kind of scary and intimidating for people to learn. So hopefully we can get you used to what Git is actually intended to be used for in real-world practical applications, not just for submitting your homework assignments. So let's start by talking about the Git repository. Oh, sorry. Excuse me. The Git repository structure. Every Git repository is going to be hosted in the cloud somewhere. And so typically that means github.com, right? That's the one that most people know. And I will be using that one today because that's the one that I expect most people have access to already. That's where I keep all my stuff. But there are others. GitHub is not the only one in town. Bitbucket exists. Or, I mean, you can also, if you're a big enough company and you want to, you can set up your own Git, installation on your own computers, on your own servers, if you would like. So it's entirely possible to have it in whatever configuration you want. But we're going to use one of the most common ones, which is hosting our repository on the cloud on github.com. I'm going to go ahead and create a new repository right now, just for the sake of this class, just for practicing. I'll call it Git Practice 24 to distinguish it from the other ones that I've done. So we're going to create a brand new repository. Just to kind of explain what some of these options are, I can zoom in so you can see a little bit more as well, right? You can give it a description if you would like to. Or a lot of times what people will do is they'll add a README file. In fact, this is sort of a sneak preview for what I'm going to be expecting you to do on the project, actually. README file comes, I'll show you an example in a little bit when we get there. Talk about that a little bit more. Using git ignore is also another very common tool. So I'm going to go ahead and select one of these for Java right here, since that's the language that I'm going to be using in this class. Now you saw there were a whole bunch of other options based on what kind of coding project you want. I'll talk a little bit about why that is the case a bit later on. I'm not going to get into licensing in this class. That is something that I'm not honestly too well versed in myself. So I'm just going to skip it. And I'm going to go ahead and create a repository, and then we'll take a look at what actually got created and what we can do with this information. Starting with the README file, that's one of the more obvious ones. It actually gives us this empty text here that we can edit This is in a language called Markdown, which is a very common. I hesitate to even call it a language so much as a way to just annotate your text. If you're familiar with HTML, taking any kind of web dev, it's in a similar kind of vein. So not something that's very difficult to learn, and they will help you. But this is a very common way of just explaining what this project is. I'm going to ask you to use it to give me, reports on your projects later on in the semester. So every time we go through an iteration, I'm going to ask you to update your README file and say what you did that iteration and a whole bunch of other stuff to explain what's going on. So you'll get the hang of updating these. We'll take a look at the get_ignore file in a bit. What I would like to do before we do that is make a copy of this repository. So right now this is only online. This is only on the internet. You can edit files directly through the website. Sometimes actually students will do this in my classes, and I don't like it. It's actually not a great idea, I think, in most situations to edit files directly through the website. But you can do it. You can actually click on any of these websites, any of these files, and edit them if you want to. I prefer to do most of the manipulation on my computer. So if I'm writing a Java project, that probably means Eclipse, right? Or if I'm doing Python, then probably VS Code or whatever text editor IDE that I want to. So I need a way of getting this repository information onto my actual computer. And so that's called cloning the repository. In 131 and a lot of the other classes where we introduced it to you, we have you do this through Eclipse. So we actually say right click here, click on this button, all this stuff happens, yada yada yada. If you're TAs, you know this process very well. Actually, everybody knows it very well because you do it a bajillion times over the course of the semester. I want to show you how to do it on the command line today. I think it's very important to know these commands, how to interact with these commands on the command line. So that's the way that I'm going to do it today. That's the way I'm going to ask you to do it when we do exercises today as well. So what I'm going to do is I'm going to come up here and grab the link to the repository, copy it in whatever way makes the most sense to you, and I'm going to switch back over to command line, which I've already opened up and gone to a directory where I want to work on Git stuff, right? So if you need to change directories on your computer, obviously you won't have this directory because it's got my name on it. You probably have different directories. So think about where you want to put your files. Think about where you want to put your repository. Once you've used the cd command to get to an appropriate location, we can start running git commands, starting with the very first one that we need, the clone command. And then we'll go ahead and paste that URL right afterwards. That should do it. That should be the entire command. It'll actually create a directory that has the same name as the repository. So once I'm finished, I can verify that everything worked okay by running ls, and I can see that this folder is what got created for me. This is the directory that got created for us, that got cloned. And so what I actually have now is a copy of the repository that exists in the cloud. And right now they are exactly 100% identical. That won't always be the case though. We're going to want to add stuff and make changes. And this is the part that you already know, so I'm going to, kind of go through but I'm going to show you how to do it on the command line. So what I want to do is actually simulate what you might do for a homework assignment, which is add a file, right? And then commit and push that file. We've all done this before, I think, most of us in some of our classes. So let's go ahead and see how we might do that on the command line. First, I'm going to go into the repository. And I just get in the habit of running ls. We see that, all right, the README file is there. There's actually more stuff there than that. There are what are called hidden files, and if you want to see them, you have to run ls with an extra flag, probably dash, that's not it, dash a. There we go. Actually, you can do it with both. Dash al will give you the hidden files as well as all of the extra information. So what are we looking at here? The other files that showed up that weren't here before, there's the .getignore file that that I promise we're going to talk about a little bit later. This one is, this is actually a directory because it's highlighted. We know it's a directory. It actually tells us over here as well. Where's the D for directory? This .git directory is what stores all of the information about the repository. So actually, you should never really have a reason to go in here and mess with this stuff. If you do, it could cause some unintended side effects. It could cause the repository to stop working, right? But when you run git commands via the command line or even Eclipse, whatever you're doing, it's modifying the files in this directory to keep track of everything that happens to the repository. So there is important stuff here that Git is using. That's actually what gives Git the ability to do what it does, but that's not for people to touch. Good to be aware of it, though. Good to know that it's there. So I want to add a file. There's a few ways we can do that. I can just open up Vim with the name of a file. We could do code. I think actually on, I'm not going to do code today, but on Monday's class, I actually want to show you how to compile and run Java code via the command line as well. So that's something that's going to be coming up on some homework assignments. But for now, we'll just do some text just to keep it simple. And I'll just, put in a message. Doesn't really matter what the message is. I'm going a little fast because we've talked about Vim enough, but if you get stuck, definitely ask a neighbor. If you need a reminder how to exit Vim, don't be ashamed. It's a common problem. If I run ls now, we see that, okay, that file now exists. It has my little greeting in it. At this point, we may want to check the status of the repository, which we can do by typing git status, and it will actually tell us that there is an untracked file, meaning that this file is new. It hasn't been included as part of the repository yet, but it's also telling us what to do here. It says use git add to include this file as part of the repository. So that's actually what we're going to do next. I'm going to say git add, and I'm going to say hello.txt. That's the name of the file I wish to add to the repository. You can add more than one file at a time, right? So I can type out multiple files if I want to. But regardless of how you do it, in order to include it, you have to run this add command first before you can actually do the stuff that's coming up next. Oh, this is a fun little warning that you'll probably see if you're on a Windows machine like myself. This is not super relevant to Git, but just to explain what you're looking at here, especially if you see it on your own machine. Windows and OS X/Linux can't agree on how to terminate lines. They both do it different ways, and it causes problems to this day. So that's why you see fun little error messages like that. Git's trying to help me out here by converting them to make everything happy. So yeah, I'm going to ignore it and pretend like everything's fine, because it is. Back to the task at hand. Once we've added it, we can actually, running git status is never a bad idea. It'll tell you exactly what's going on, right? And at any given point in time, it says, okay, now I see the file, it's new. We actually need to make a commit. So I'm going to say git commit. And then every time we make a commit, if you remember from doing it in Eclipse, there is a non-optional step, which is you have to add a commit message. So in Eclipse, you do it in the box. You usually say assignment 1 done, or whatever the case is, right? And that's what you're supposed to do. Just give a little message as to what changes have been made for this particular commit. So, I'll just say I'm adding greeting or something like that. The -m flag after commit is therefore required when you're doing it via the command line, and you have to put your message in quotes, commit message in quotes. Okay, we have now made a commit. However, we're still not quite done yet. Remember, we actually are operating on a clone of this repository. We're operating on a copy of this repository. So the commit that we have made has not actually been sent to the cloud yet. We would call that the source of the repository, or the remote of the repository. And so in order to do that, we have to do the second step, which in Eclipse, it does it all for you in one shot, right? The button says commit and push. But they're actually two separate actions. And that's something that I want to talk about in a little bit more detail, what actually is happening when we commit and push. But to finish the process as we know it, it's generally as simple as just saying git push. And here we are. We see what it's saying. It's telling us that it sent 331 bytes of data. Okay, cool. What we know to do from class is to now go back to github.com, right? And if I refresh the page where I created this repository, I'll see that there's the file that I created on my computer. It did not exist until I ran that very last step. So I would not have been able to see this file on github.com until I did that very last step of pushing it from my computer to the remote version in the cloud. I don't know, why does it say 2 days ago? Is the date on my computer off or something? That's a little weird. Why does it say 2 days ago? Huh. I have no idea about that one. Anyway, let's talk about the differences between committing and pushing, because I think that's actually very important, especially for the conversations that we're going to have about the more advanced Git topics, because so far we've just done everything that you've done in class, right? I just showed you how to do it on the command line. There's a whole lot of other stuff that you can do with Git. I want to talk to that as well. But in order to understand it, I think we need to understand the difference between committing and pushing. So in order to think about Git's view of the world, we have to imagine it as a timeline, right? So it's literally keeping track of a project over time. And when I'm making a commit, I'm actually telling Git that this is a snapshot. I want you to remember the repository exactly as it looked right now at this moment in time. So it's like I'm taking a picture of every single file exactly as it looks, right? And then saying, all right, remember this. This is exactly how it looked at this date, at this time. And so that's a commit. That is what a commit means. We can make multiple commits. It's really just multiple snapshots along a timeline. And then actually what I'm going to show you a little bit later on is that we can go back at any point in time to any one of them that we want to and look at it again. See the state of the repository, see the state of the code as it existed at that moment in time. So that's what a commit is. A commit is just recording that snapshot, recording the state of the repository at that moment in time. The pushing is really just an act of communication. The pushing is just the act of saying, oh, here are the commits that have been made. I want you to have them, right? I want the cloud to have the same information that's been made on this computer. And the nice thing about that is that for bigger projects, it's not just me working on it. It's going to be 10 people, 20 people, hundreds of people working on it, right? So those commits are going to be coming from all over the place, many different computers, but all congregating there in that centralized point of the GitHub.com repository, the remote repository. So the push action is just communication, just taking the commits that you've made and sending them to the cloud. That's also how we communicate with our teammates. If I don't do that, they can't see the changes that I've made. Yeah, question?
So if you have multiple commits and then let's say commits and then push, does it commit all of, does it like push all of the commits or just like
It will, yes. Yeah, that's a great question. If I make a bunch of commits and then I do one push, it'll send all of the commits that have been made since the last time I pushed. Yep. Great. That's a great question. Yeah, pushing really is just an act of communication. It's the commits are the act of recording that moment in time, and push is just making sure that the clone on my computer is in sync with the remote branch. Yep. It often can be useful too to do exactly what you're saying and make multiple commits before pushing. That's not an uncommon thing to do. Alrighty, we're gonna stop right here because while I know you're all familiar with committing and pushing at least a little bit, I hope, the command line stuff is new and I want you to try it out. So I'm gonna ask you to basically do the exact same thing that I was doing. Maybe some of you were following along, but I know that this can be a place where people get stuck. And so this is a good time to ask for help if, not get, I wanted to do cat, sorry. Yeah, this is a good time to ask for help if your Git isn't set up properly or not working properly or something like that. Flag me down, I can help you fix most problems, and if not, Google will help you fix the ones I can't. But yeah, I'm basically asking you to do the same thing that I just did. Make a repository, clone it on your machine, add file, commit it, and push it, then check and make sure it made it to github.com. What's up?
So I have to like kind of look them up.
Yep.
One more that push.
Okay.
GitHub.
Yeah, so that's going to be a personal access. So you'll have to make a new one, command line, which you probably haven't done since 131, something like that. But settings, and then all the way down to profiles.
Should I get a copy of that?
Remember when you did there?
Oh, you own it? You can.
Alright, it's gonna say no.
Yeah, it's very.
Oh, okay, yeah. It's under settings and then developer settings. So you'll have to make a new personal access area there. The class is generate a new one. Class and then I'll like command line or something, or yeah, class. Make sure you check the little box. Yep. Scroll all the way down. Oh yeah, I would set it to zero. Scroll all the way down. Generate, and then when you do a git command, you need to use that.
Okay. So if I
So
push
run,
up.
yeah, go ahead, run your push. Username,
I love how it's not like this.
paste it. There you go.
And then would I need to do that every single time I wanna
Well, so actually, run git push again and see if it makes you want to do it again, because there is a way to make everything personal.
Oh, I see.
See, it's going to keep prompting you. Let me give me a second.
Okay.
Sometimes I type too fast. What are you doing?
Trust.
Yeah, how's that easy?
I mean, so you can just like paste that thing in a file somewhere, but it's kind of like
No.
the alternative is to start digging up the stack a bit more.
Can you continue on and still?
I mean, obviously there's a way to do it because I got my place right here. I don't know why I'm talking directly.
What? How far down is it?
Oh, it is.
Oh, dodge that.
Here you go.
How much space do you have on the other one? more about the whole process of this?
Maybe type it in. Control C. Now I'm gonna take push. We'll have to type it in.
Is the page for audio or no?
Thank you. Appreciate it.
How much are the other ones? Like the other ones more or
So
just
again,
roughly?
okay, so you can actually
Because
have
what, I guess this is for you, and I'll just on the next one. What are you supposed to do? After the software. Yeah.
Space store.
Unfortunately,
Now
my
do
cousin's
like a get
girlfriend,
full.
she's even mad. She went to JP Morgan to buy the last summer, and she's like returning, but she like just hated it.
Yeah, I've heard JP Morgan.
Yeah, she would actually. Yeah. Do you have one? Like a is Guggenheim one?
For last.
Okay. So who is it?
That works. Now if you
What
hit
is
push
it?
button, it should ask us your password.
What's the download?
Here we go. You can get personal access to
There's this
the
thing
computer, so like
where one of the person's like super high. Sometimes I think I couldn't really figure out like how far I could go based on just that question and no interest in business. And I think it would be very not far.
I was gonna try having friends that
Oh my goodness, that's so true. I was like, so there's actually no choice. I didn't think there would be any choice. It won't be, I don't know.
his dad gets in a photo of VP or yeah.
that's your address. Make sure to set it to never expire.
Does your dad do IT?
He lives in the city.
So
Both
it's
my
like,
parents live in the city, so they have a photo.
then no shadow.
I wish.
How's everything else? Like, how's everyone else doing?
Pretty good. I mean, it's still
Yeah.
this is on the tap on the last bit.
That's super exciting though. Trying to get out of course, but you know what?
They can take my money, right? Go do fine. Thank you.
Yeah. I think it's really cool. It's just like wow. If you get this one, there's like it just shows that like others are taking it seriously or I can put
Now's the time to practice.
but also you know it'll be fine. You'll be great. What are you studying? Guys, so
Okay, sorry if I didn't get to your Git problem. I know Git can be finicky. I tried to help as many people as I could. If you are still having Git issues, don't worry too much about it. We can there'll be more time for us to do practices, exercises, and stuff. Also, I've got time after class. I can help you out after class if you have a few minutes to stick around. If I didn't get to your Git issue. But I do at least want to try to keep moving on to some other stuff. So hopefully that exercise went well for you. I'm not going to go through the steps again. I just went through it. I think it's important for you to go through it. That's why I asked you to do it. So hopefully you didn't run into any roadblocks. If you did, come chat with me after class, or we'll figure out a time to fix your problems. For now, though, I want to talk about Excuse me. Some more advanced Git topics, and what I'm going to talk about is going to make Git feel even more complicated than it probably already does, but it's actually a very practical, very real-world usage of Git. I want to talk to you about branches next. So I described Git repository earlier as a timeline, as a timeline, and commits as checkpoints along that timeline where we're saying we wish to remember the repository at that moment. A branch is quite literally then creating an alternate dimension or an alternate timeline, if you will, that runs parallel to all of the other branches. And we can make commits to those individual branches that cannot be seen by the alternate, the other branches. So one way to think of a branch is sort of a protected little workspace for you to make your commits on, right? In fact, that is often what branches are used for, as a way to silo different parts of work. So if I have a very big project, lots of people working on it, maybe they're all doing different things even, right? I'm going to make one branch for each section of the project that I've got people working on, so that those people can work within that branch without necessarily having to work about the changes that these people over here are making, interfering with that work. It provides a little sandbox, it provides a little protection. Now eventually, we do want to take those branches and merge them back together, because the finished product is going to include all of that stuff. It's not just going to include parts, it's going to include all of that stuff. So we need to have a way of taking those timelines and merging them back together, which is effectively taking all of the commits that exist on both and just squishing them down to one. I'll try to visually illustrate this in a little bit once we actually start creating some branches, but I think it's important to note that throughout this entire process, we are also making commits and pushing them to the cloud, right? The branching is happening in addition to those things, not in place of those things. So let's take a look at some simple branching commands and talk about the effect that has. I'm actually going to bust out my fantastic MS Paint skills and draw some things, try and represent our repository. Right now, this is the visual representation of the repository that I've got. It's just got one commit. I just made that one file and made that one commit. That's it. That's all I've got. What I want to do next is make a branch. And just making the branch itself is quite literally just creating a second timeline out here, right? This branch is typically what's going to be called the main branch. So whenever you actually create a repository, it has a branch in it. We don't often ask you to use it in our classes, but it's there. It's called main branch. I'm going to create a new branch, and typically that new branch is going to be based off of whatever task I'm trying to accomplish. So I'm trying to add a new feature to my application. I'll name the branch after that feature that I'm trying to add, typically, off of the thing that I'm trying to add to the application. I definitely am not going to name it after myself. No. Very tempting to do, especially on group projects, and I'm saying this for a reason because I see it every semester. I'm going to ask you to do a group project later on in the future. Do not name the different branches after the members of the group. That is not how I want you to do it. That is not how it's done in real life. If I want to know who's done stuff, I can look up the commit logs and see exactly who made those commits and what commits they made, right? That information is all being tracked. I would rather track the information based on what's happening to the application in this branch. So I'm going to add a branch to our very simple repository right now by using the checkout command with the -b flag. So the checkout command is actually how we switch branches. Checking out is the act of moving from one branch to another branch. When you add the -b flag, that's an indication that I want to create a new branch. So the branch that I'm asking you to go to does not currently exist. It's going to be created as a result of this as a result of this command. So I'll call it new greeting or something like that. Doesn't really matter what the, whoops, I'm not in my repository anymore. So this is what this message means. Actually, let me take a moment to explain. If you ever see this, that means you ran a git command, but you're not in a git repository. So you need to cd into wherever your git repository is. Very common thing. I do it all the time. I need to cd into the repository, which was called git practice. Yeah, there we go. And now I'll rerun that command to create a new branch, and hopefully since I'm actually in a repository this time, it'll do the thing. All right, switch to a new branch called new greeting. Right now, this picture is accurate, right? I could label the branch if I wanted to with the name, but right now, the label or the way that this looks is an accurate reflection of the Git repository. They share the same history. I haven't made any commits yet on either the new branch or the main branch. But as soon as I do that, then their history looks a little bit different. Then their timeline looks a little bit different. So let's take a look at that. We can actually do that and see the effect that it has on our repository. I'm going to add another file in my new branch. I'll call it greeting2, I guess. Doesn't really matter what I put in here. So I see hello.txt. That's the first one that I committed and pushed before we started talking about branches. I now have a second file. I can run git status, which now not only tells us about the new file that it sees, but also is reminding us that, oh yeah, this is the branch you're on. That's good info, right? I definitely want to know what branch I'm on. Definitely want to make sure I'm making commits to the right branch. I wish for this file to be included as part of the repository, so I'm going to run the same steps. I'm going to add greeting2.txt. There's that fun warning again. I'm going to make a commit. And at this point in time, I have to update my diagram. The act that I've performed on this repository has the effect of making a commit, but only on the branch where I currently was, right? So that's the commit that I just made with the second file on it. Let's think about the implications of that for just a second. Like, what does that actually mean, the fact that the commit is up here and not down here? Well, if I come, first off, let me show you that I can see a couple of other useful commands. Here's a command that I can use to see all of the branches that exist. So main and new greeting. Main and new greeting. Anything that starts with remotes, that's not really information that's relevant to us. That's from github.com. So we're going to let github.com worry about anything that's marked as remotes. It's not super relevant to us. These are the branches that we care about. Main is the one that we always get. This is the one that I just created, and it's the one that I'm currently on. It's highlighted, so it's telling me that's where I am. But we can actually switch. We can switch branches. So the command to do that is called checkout. So if I check out the main branch, I am now viewing this timeline again. The main branch is the one down here. There's only one commit here. This commit that I just made does not exist on the main branch. So if we think about the effect that that has, just running ls shows us that that greeting2 file that I created is not here. That commit was made on a different branch. It does not exist here. Does not exist here. We can actually verify this in some other ways. Here's a nice trick to be able to do. If I type git log, it will show me a list of the commits. So I can see that here's the first commit that was made when the repository was created on github.com. And here's the one that I made that I don't know why things have happened on switch back to the other branch where I created that second file, I can say git checkout, what did I call it, new greeting. I can run git log again and see that it contains the initial commit, the first commit that I made, and the second commit that I made, right? And after I switch branches, if I type ls again, poof, there is that second file. It just materialized out of thin air, right? Well, it's there the whole time. It's just on the alternate timeline. It's just on the alternate branch. Again, why do we do it this way? It's so that if I have multiple people working on different parts of the project, they don't necessarily interfere with each other. They can add code without having to worry about what some other group is adding at the same time. It kind of isolates us. But we still have to talk about what happens when we need to reconcile, because that does eventually need to happen. We can't keep things in siloed off branches forever. We're eventually going to want to merge those branches back. Before I do that, I'm going to make one more commit, I think. I'm going to check out the main branch again, and I'll make a new file called greeting3. And I'll add it, and I'll commit it. And now, if I wanted to think about what happens with my diagram over here, I have another commit down here on the main branch. Think about what that means. The file that I created on the main branch can only be seen on the main branch. The file that I created on the new branch can only be seen on that new branch. And if I want to see those files right now, as things stand, I have to check out the branch that contains them. Switch back and forth. Everybody with me? Any questions? This is kind of the mind-bending part, so don't be afraid to ask me to go back over something again. If it's still not kind of clicking, it took me a few tries to understand this myself, to be perfectly honest with you. Okay, so what we eventually want to do is something like this, where I want to merge these branches back together, right? And think about what that actually does. The effect of that is to flatten essentially these timelines together, so that now when I look backwards from this point, I'll see all of the commits, not just one or the other, but all of them. So we are merging the timelines together, and that is the corresponding command that we would need to run. So if I go back to the command line, I'm going to double check and make sure which branch I'm on first. Okay, I am on main. That is the branch that I wish to merge into. So I wish to take the new branch and merge it into the main branch. I'm going to run git log right now just to kind of refresh our memory. We have, the first two commits and then one special commit that only exists on the main branch. I'm going to merge in the new greeting branch using the merge command. It's actually dumping us into a text editor. You can see what it's asking us to do. It's saying enter a commit message to explain why this merge is necessary. The main reasons why merges are necessary is because you're getting prepared to consolidate all of the new things into a single branch to get ready to release it to the world. That's known as releasing your product, right? Releasing your program that you've been developing. So that's the most common, often reason cited in this example. This is not Vim, though. This is actually, I believe, the Vim's main competitor, which is called, is this Emacs? I think it's Emacs. Vim and Emacs have been battling for command line text editor supremacy since before I was alive, which is a long time ago now. Anyway, regardless, I'm going to hit Control X to get out of here, if I can, please. I don't care. Okay, oh, I did it. Fantastic. I hit Control X for exit, and just follow the prompts to get the heck out of there. And it's telling me that the merge was made successfully, which is good. That's hopefully what we want to see. If I type ls now, I can actually see that both files exist in the same place at the same time. Right? So there's greeting 2 and greeting 3. And if I run the git log command, I'll actually see that it contains all of the commits. Here's the one, well, I need to actually scroll down to see them all. Here's the one that was made on github.com. Here's the very first one that I committed and pushed. This is the one that was made on the branch. It even tells you which branch it originated from. Originated from the new greeting branch. Here's the one, since it doesn't say the branch, that means it's this branch, the main branch. And then finally the commit for the merge. So actually, I suppose to fairly update our diagram, have to reflect the fact that there's a commit that takes place here at the merge. The bigger point, though, is that from this point forward, since those branches have been merged, if I look backwards, I see all of them. It's like they've been all smashed down together onto the original timeline. That's the effect of the merge, is to take the commit histories and kind of zipper them up together so that it looks like they all happen on the same timeline. Any questions? Yes? So because this commit existed when this branch was made, this branch did contain it, right? So any branches that are made will contain all of the past history, right, from the branch that they were created off of. Now, the thing to keep in mind, and what we actually haven't talked about yet, is what's an actual. We actually have this concept of appropriate branching strategies. So when should we be making branches? When should we be merging branches? We actually care about these things a lot. Because we're trying to avoid the situation where we have commits taking place on multiple branches that interfere with each other, which still can happen, and is known as the dreaded conflict that maybe you run into at some point when working with Git repositories. So I successfully navigated these branches without making conflicts. That's great. But I do want to show you what happens when things don't always go according to plan. And once we do that, we can talk about appropriate branching strategies, when to use branches, under what circumstances. But let me show you a conflict. Let me show you how we can make a conflict. There's actually more than one way you can do it. There's different types of conflicts that exist. But I'll show you maybe some of the more common ones. One of the more common ways to do it. And I'm going to do it involving branches. So I'm going to make a new branch. I'll call it, I'm sorry, it should be -b. Conflict branch. Okay. And because I just created this branch, it's brand new, the history is exactly the same as the main branch. Right? Whenever I create a brand new branch, they share the same history. Only until I start making commits do those branches actually differ in terms of what they contain. So that's what we need to do next. And what I'm going to do is I'm going to open up the same file in 2 different branches and change it in 2 different ways, right? So my computer thinks it's Monday, so I'll change this to say Monday. So I modified an existing file. I opened it up. I mean, you only need to change 1 letter, honestly, for it to count as a change, as a modification. I'm now going to add it. Notice that I still have to add the file, even though it already existed. Because I made a change to it, I still have to add it. I still have to say that I care about this. If you're thinking about doing this in Eclipse, This is the equivalent of taking a file from Eclipse and dragging it into that box that says staged changes. That's what the add command is doing. That's the equivalent operation. I'm going to go ahead and do my commit. Okay. Now I'm going to check out the main branch. And if I look at the contents of the file, it still says Wednesday. Right? Hopefully that's not a surprise. The change that I made to this file took place on a different branch. So until those branches get merged, they don't know about that. They don't know about those changes that take place. They're independent. But okay, I'm going to make a change here too. So I made it say, you know, Monday on the last one. Here I'll make it say Friday. And I will add the file. And up until this point, we don't actually have any problems. We have the potential for a problem. We're headed on a collision course of sorts with these commits. The problem is going to exist when we do the merge. If we think about this diagram, I mean, it's very similar. The big difference between how we did things on the last example with the branching versus how we did things on this example. In the last example, this was for a brand new file that only existed on this branch. This was for a brand new file that only existed on this branch. The difference now is that this commit is changing the same file that exists on both branches as this commit. That's the difference. That's a conflict. That is the definition of a conflict. Quite literally, the definition of a conflict is two people making changes to the same file on different branches. Or the other way that you can do it that's very common is two people making changes to the same file on a different clone of the repository. So not even necessarily a different branch, but just two different copies, right? Which is probably, if you run into one in class, like 131, that's probably what I would expect to see. In professional development, this is the more common way. A merge conflict is the more common source of conflicts. Two people are working on different parts of the program, but the code that they're working on still requires them to manipulate the same file because there's maybe some shared code, right, as part of this project. So they're both in there manipulating that shared code, and then when the time comes to merge everything back together and make sure that all the new features are, you know, cooperating and working together as they should, we have an issue. So let me show you what happens by coming back over here and performing the merge. Which branch am I on? I'm on main. That's good. So I'm going to merge my conflict branch into main. Conflict branch, is that what I called it? Can't remember if that's the name I gave it. Okay, there we go. Yeah, it was it. And we got the dreaded conflict. Tells us it's a merge conflict. It tells us where the file, what file the merge conflict takes place in, hello.txt. It then says to fix it. How the heck do you do that? Well, let's open the file. This is what you'll see. Maybe you've seen this before. You run into a conflict. Eclipse will definitely show this to you if you run into a conflict in Eclipse. Here we're just looking at it in Vim on the command line instead. It's showing us the two different versions. It's quite literally saying that on the main branch, it looked like this, and on the conflict branch, it looked like this. That's quite literally what's showing us. The lines with the arrows have been added by Git. The equals have been added by Git, just as formatting to help us see the two sides, right? So how do we fix it? We just make it look good. Make it look the way that we want. We have to pick one, right? The computer doesn't know which one we want. It's not going to be able to make that decision for us. That's our job as the programmer, is to look at these two different versions, say, okay, there's some overlap here, so I'll keep the overlap, and then I see there's some new stuff here that needs to be carried over, some new stuff in this branch. That's our job, right? Go through everything, get the other team in on it if you need somebody to explain, what code they did in their branch, right? And then decide what you need to keep and get rid of the extra stuff. So I'll just start removing the lines, and which one do I keep? I don't know. Both. You can keep both. Get rid of one. Doesn't matter. It's up to you. Think about what your project needs. If it's code, you're obviously going to want to test it, right? Remove the extra code and then test it. Make sure it still works. Regardless of how you get there, once you have cleaned up the file to resolve the commit, all you have to do, to resolve the conflict, all you have to do is add it and commit it. Conflict has now been resolved. So if you ever see Git telling you that you have a conflict with a file, or it could be multiple files, right? It doesn't just have to be one. It's possible that multiple files are affected. You got to open the files and look at them and decide what you want to keep. Decide what needs to be gotten rid of. That's your job. Git will not do that part for you. But once you've done that, just add the files, commit them, and you're good to go. Conflict resolved. Conflicts, while scary and not necessarily a fun part of programming, they're inevitable. It's pretty much a guarantee that they're going to happen. So the goal is not avoidance. The goal, obviously we want to try to avoid them if possible, but the goal is also to accept them as part of our daily life and be ready to tackle them when they occur. Because it's going to happen. It's definitely going to happen. Are there any questions about that process? That is by far one of the things that I get asked about most often. So happy to go over it again if that would be helpful. Just a couple more things before we probably do another exercise or two to wrap up for the day. Question for you all: if I go to my GitHub page right now, what am I going to see? For the stuff, what am I going to see? Anybody know? Where is that repository? That's from a long time ago. I have too many. Here it is. So I still don't see any of the stuff that happened after the very first commit and push that I did, because I didn't do any pushing. I didn't push. I made a ton of commits, made a ton of branches. I didn't push any of it. Not push any of it. And that's okay. That's totally okay. But just understand that pushing is the action of taking what changes I've made on my computer and sending them to the cloud. So if I want to see that stuff on github.com, I have to remember to push. Now if I come back here and refresh, we'll see all of the files. We can also see, so it's telling us that there's only a main branch, which I think might be technically correct since I did merge the other ones, but it is possible to push individual branches as well. So if I check out my conflict branch, for example, and I run the git push, here we go. Well, what did it say? Has no upstream branch. To push the current branch and set the, well, okay, we'll do exactly what it says. Git push. What is this error message telling us? This error message is saying that I see that this branch exists on this local clone of the repository. I don't see where it exists on github.com. When it says the current branch has no upstream branch, that means github.com. I don't know where it is on github.com. That's because we created it here, right? I created it on that computer. not created on the remote copy on github.com. But the nice thing is it's telling us how to fix it. It's saying, all right, here's the command that you can use to create this branch on the origin, which again is another word for github.com. Anytime you see origin upstream, we're talking about cloud. We're talking about the copy that exists on github.com. So if we run this command, we'll see that it's possible to also see all of the branches on GitHub as well. This is very useful, again, if you have a large project with many different branches that exist. All right. Trying to see where I'm at in my notes, what I want to do next. Okay, we've only, I have some more exercises for you to do. I'm just worried about the timing. So I think I might show you one or two more tricks, and then we'll start class next time by doing a lot more hands-on practical stuff. So what I would like to show you next has to do, again, with the logs. Again, remembering the idea that each one of these is a snapshot of the branch that we are on at a given moment in time. You can see the dates tracked, although, again, I don't know why the date's wrong, but it's tracked for all of them. This here is actually a number. It's a commit number. It's an ID number. It's intended to be unique. That is essentially the ID number for that commit, which is useful if we wish to actually take that look back in time and see what the repository looked like at that moment. So for example, if I wanted to go back and view how things looked, right after that first commit that I did, the way that we can do that is to just take a look at the first few. We don't need to memorize the whole number. Actually, just the first few is usually enough, so F613 is probably good enough. We can actually check out a commit. F613. So it's telling us that we are in detached head state. Think about what that means in terms of the picture of our timeline. The head is whatever commit is most recent. That's where we're at now, right? The most recent snapshot, the current state. So when it says we're in detached head state, that just means that we are not looking at the most current commit. We're looking at one of these ones back here. We're looking at the repository as it existed in this moment in time. And so if we take a look at the files, we'll see that the greetings don't exist. This was before I even made a single branch. This was way back, right? Way back. This is very useful for the case where you add something to the program and then later on discover that it was a horrible idea, right? Or that it breaks a lot of stuff, or it gets in the way of lots of other parts of your program. Maybe I wish to return to a state before that thing existed. Move it from existence as far as my program is concerned. You can grab copies of the files that existed back at that point in time, and then when you're ready to return to the present moment, you can just check out the main branch again, which is going to bring you back up to wherever the current main branch is. And so I think the last thing that I want to talk to you about today is actual branching strategy. I'm going to do one more diagram to wrap up. In practice, what should things look like? And this is good for you to know, not just for the practical sense, but also you're going to be graded as part of this on your projects at the second half of the semester. Is your repository clean? Are you using proper branching strategies? So our main branch, let me take a step back. What I am describing to you is one branching strategy. It is not the only branching strategy. The correct branching strategy to use is whatever strategy is in use at whatever company or organization you're working for, right? So this is the one that I'm asking you to use for this class. I'm your boss in this class, so this is the strategy that I'm asking you to use in this class. It is a common one. I wouldn't be surprised if you ran into it out in the wild. So the main branch, we don't touch it. We do not ever, 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 ever make commits directly to main. Ever. Ever. That's like exactly the opposite of what we tell you to do in pretty much every class that you take here, right? So sorry about that. I don't think that's actually a very nice thing that we do, but in the real world, we don't touch main. Why? That is what the world sees. That is the public-facing version of our code. All of the other branches that I'm about to talk to you about are used behind the scenes for the developers, for the people working on the project. That's not the stuff that we want, the average person to see. We want them to see the finished product, the polished finished product. So main, that's our release branch. When I release version 2.0, right, that's quite literally me merging branches into main. That's how stuff gets into main, only via merging. Never making commits directly to main. Branching off of main, let me label these actually. So main's down here. Branching off of main, we'll have another major branch. This one is usually called the development branch, or dev for short. So you can think of dev as kind of being a secondary main of sorts. It's the main for program developers, right? If you are interested in working on this project as a developer, then the development branch is probably your starting point. That is where all development work originates from. And so if I'm a developer, we'll talk about project management a little bit when the project gets closer, but I'm going to be assigned a task, right? It's my job to do thing X. And so once I've been assigned that task, then I'm going to come over to the development branch, and I'm going to make a branch off of that branch. So here's my branch. And this one I will label with the task that I am, that I am doing. I'm adding thing X. If there are other developers working on other tasks, they will make branches off of development. So here's another developer that is making another branch, right? It'll be labeled with whatever task they're working on. They're working on thing Z, right? That label is a little confusing. There we go. Okay? So off of the development branch, there's going to be a whole bunch of what I would call feature branches, right? Or new things that are being added to my program, to my project. Once I'm finished with my task, I believe that I've completed the work, I've tested it, it's working the way I expect it to, I'm ready for, there's probably going to be some kind of a peer review process. I'm not going to talk about that today, we'll talk about that later. But assuming it's passed all of those checks, it's ready to be, given to the world at large, merged into our program and becoming a public part of our program, then we start merging. So, I'll take all of the features that I care about and start merging them into dev as they get completed. Once I have accumulated enough of those features, that becomes what we call a release. Right? A release contains many features or bug fixes or both. So once we've accumulated enough of these branches, enough of these new features on the development branch, I will create a release, which is merging the development branch into the main branch. At that point in time, because of how merging works, right, all of the commits that exist on these branches now become part of main, therefore an official part of our program that the outside world can see and use. Notice that the development branch does not cease to exist, however. It always constantly runs in parallel to main. Always. Right? It's the staging area for any work in progress before it gets released. Does that kind of make sense? I hope. Yeah, so this is exactly what I'm going to be asking you to do on your projects. And yeah, you'll be graded on this in terms of, I mean, obviously if I see you making commits to main, that's something I'm going to be calling out, but I'm also going to be looking for the thing X and thing Z branches being named after tasks, being merged properly into the development branch. All of these things I'm hoping you'll get a chance to practice. But one more time, just to kind of make it clear, everything that I've shown you today, some of it you've already done via other tools like Eclipse. Everything else that you haven't done in Eclipse, you actually can do in Eclipse. So if you want to take a look deep in the menus of Eclipse, are varied ways to merge and make branches. You can do all that stuff. And one other thing that I think is also very useful for you to know, as it relates to Eclipse and other IDEs, since we're on the topic of Git, I'll show you one very common thing for me to do. If you're using Eclipse or another IDE to manage your repositories for you, those repositories still exist. So here is where all of the Eclipse repositories get downloaded on my computer, right? It's just in my home folder, in a folder called Git. So anytime you've been asked to download a repository in Eclipse for class, this is where it ends up on your computer, in your home folder, in a folder called Git. And these are actual Git repositories. So if I want to, I can CD into any of these, right? These are for a different class, but it doesn't really matter. And if I look at these, I can see the files, and I can even start running Git commands within here, right? So it'll actually show me information relating to the repository. And any changes that I make to the repository in Eclipse, so here's the same repository in Eclipse, right? If I come in here and I actually make changes to some of these files, start doing stuff like that, it'll actually show me there that file was modified, right? So one thing that I kind of get in the habit of doing, for better or for worse, I think it's convenient actually for me, is I'll code in Eclipse, but I'll run my Git commands on the command line. Or maybe sometimes I'll feel like doing it in Eclipse and I'll run the Git commands in Eclipse, but actually it's the same commands. It's the exact same commands. So whether you do a commit and push via Eclipse with your projects like you're used to doing for class, that's quite literally running git add such and such, git commit -m quote such and such and such and such. And if you run those same commands on the command line, it'll have the exact same effect as if you did them in Eclipse or some other tool. I think it's very powerful information to know, very useful thing to be aware of. You can mix and match and use Git in the format that's most convenient for you. Command line is really great once you get good at it. It's so fast. So you don't have to stop using Eclipse, but I generally prefer running it this way. All right, that's enough Git knowledge dump for now. I promise you on Monday we're going to do a lot more exercises. I'm going to get you typing a lot of these commands out on the command line on Monday. I want these things to kind of stir around in your brain for a little bit. If you had trouble with Git, I didn't get that addressed earlier, come talk to me after class. We got a few minutes. Otherwise, have a good weekend. I'll see you back here on Monday.